Yes, Mary's there also. Now it's the Andrew. Okay.
Yeah, apologies. I had a brief technical
No
issues
problem.
before.
It's fine, Andrew. Yes, I've analyzed all the opinions and we have to consider, of course, all the opinions that you presented here. However, while concerns were expressed by some delegation regarding the assignment of carriage requirements without data based on a worst case scenario, it seems that the current improper carriage of the product, which is known to be transported in significant quantities, warrants immediate action. We need to go to some action very quickly in this case. Then I would suggest to agree with the product name and the proposed carriage requirements for inclusion in the next revision of the NPC 2 circular for all countries and with no expiry date. I advise that as had been done in the past for use in cooking oils, any relaxation in carriage requirement will be requested based on the submission of data to DESAMP EHS for the establishment of a DESAMP hard profile and the subsequent submission to the ESPH working group for a review on the carriage requirements. If you agree with this proposal, I would like to finalize this. This, I think, completes the consideration of this agenda item. If you have comments now, maybe you could do something else. Let's see. Sometimes I don't have access to my list of participants.
No one grasping the floor.
Yeah, I think yes. Now I can see. If you agree with this position, then we can consider that this completes the consideration of this agenda item. Let me see here.
We do have Malaysia requesting the floor.
Okay, thank you, Andrew. Malaysia, please, you have the floor.
It's writing. Just a question to you, sir. That moving on to this will be that the submission will be sent to ESPH, or would it be dealt with in accordance to GSAM? How does it move from here? Thank you, sir.
Thank you, Malaysia. I don't know if Loss or even Lucas could help me to advise the best way to proceed with this aspect that Malaysia has done. I think Lucas wants to speak.
Thank you, Chair. In response to Malaysia's question, the agreement to the carriage requirements suggested in document by the UK will be posted on the IMO website once PPR is over, and then shippers and shipping and masters can use it to ship home technical oil. From that point onwards, manufacturers can submit data to the ZAMP. As Lars suggested, the deadline for the ZAMP this year has passed, so there will be a time between now and March 2022 when manufacturers can gather data and submit it to the ZAMP. However, that doesn't preclude any submissions to ESPH 27 that would potentially argue a more relaxed carriage requirement as a profile. For example, if there are considerations that they need to take into account the technical considerations of the example. But I would advise that it would be best, in order to avoid going round in circles, to encourage manufacturers to submit a complete data set, or as complete as possible, to the exam PHS in 2022, assuming that any exchange with the data that's already been submitted by Finland this year don't go forward. And then in 2022, example report to ESPH 28, which will probably be held in October 2022, and then a derogation or a relaxation can be agreed. Thank you, Chair. I'll stay on in case Malaysia has additional questions.
Thank you, Lucas. Thank you. I think we finished the agenda item 3, and I think we are ready to go to the next agenda item, number 5, that is on reduction of the impact on the Arctic of emission of black carbon from international shipping. The target completion year for this output for this issue is 2021. I think we can go directly to the action and form. Preparation here. I needed to tell you that 5 substantive and the 3 information documents have been submitted under this agenda item. I recall that no working group on prevention of air pollution from ships is expected to be established at this session. I intend to have all substantive documents introduced in numerical order before opening the floor for discussion. After the introduction of the documents, my intention is to instruct the discussions as follows. First, consider final results of campaign presenting document PPR-8/5/1 from Finland and Germany, in conjunction with the 2 commenting documents, PPR-8/5/2 from ISO and the PPR-8/5/3 from IPTA and IBIA. Second, discuss the way forward with regard to the development of a standardized sampling, conditioning, and measurement protocol, taking into account the report of the correspondence group and the information provided in document PPR-8E3 and PPR-8E4 from Canada. And lastly, discuss the way forward with regard to potential regulatory options, taking into account the report of the correspondence group, document PPR-8/5/4 from Friends of the Earth International and others, and paragraph 11 of document PPR-8/5/3 from IPTA and IBIA. If you agree with this proposal, is the way to proceed now, we can go to the introductions of the documents. I see no cards, then I think you will agree with these 3 steps to conduct this issue. Thank you. Then now I invite Canada to introduce document PPR-8/5 and PPR-8E2. Canada, please, you have the floor.
Thank you, Chair. Good morning, good afternoon, good evening to all. At its 7th session, PPR established a correspondence group on the reduction of the impact on the Arctic of black carbon emissions from international shipping. The group was instructed to advance the development of a standardized sampling, conditioning, and measurement protocol for black carbon emissions from marine engines, to investigate the linkages between measurement systems and policy options, and submit a report to PPR-8. 18 member states participated in the group, in addition to one intergovernmental organization and another 12 non-governmental organizations. 3 lines of inquiry were established to address the terms of reference, resulting in the production of 9 outputs from the group. These 9 outputs are listed in paragraph 17 of the report. Of particular note is a statement on the linkages between black carbon measurement systems and policy options to control black carbon in paragraph 9 of the report. A list of ongoing and planned research to support the development of a standardized black carbon sampling, conditioning, and measurement protocol in Annex 3 of the document, and a list of identified research needs and gaps in Annex 5 of the report. The full compilation of comments received and working documents generated over the course of the group is presented in document PPR-8, Group 2. Canada would like to take this opportunity to thank the members of the correspondence group for their valuable input and participation in this work. Thank you.
Thank you, Canada. I would like to thank the correspondence group, and in particular the lady country, Canada, for your hard work. Thank you. Now I invite one of the co-sponsors, Finland or Germany, to introduce document PPR-8/5/1. I don't know which country will present the paper. Germany, please, you have the floor.
Thank you, Chair, and good day to all. Document PPR/8/5/1 submitted by Finland and Germany presents the final results of a black carbon measurement campaign. The initial results were presented to the last session in document PPR-7/8. It concluded that the aromatic content of the tested fuels is directly linked to the amount of black carbon emissions. Analysis of further data as presented in this submission reconfirmed that finding. The test campaign was conducted on a single-cylinder, medium-speed marine diesel engine. Neither the variation of injection timing nor rear pressure could compensate the different BC emission levels of the different fuels. Further, a good correlation between the BC measurement methods, photoacoustic spectroscopy (PAS) and filter smoke number (FSM) was confirmed and even improved by additional data. A detailed chemical analysis of the 3 very low sulfur fuel oils revealed that the aromatic contents of the tested fuels were 73, 83, and 97%, which consisted of 50, 60, and 76% polycyclic aromatic hydrocarbons, GAH, respectively. This raises concerns regarding their impact on the environment and human health. For the same reason, aromatic content, including GAH, were limited in automotive and aviation fuels. For the maritime sector, more data on the composition of a representative number of very low sulfur fuels are needed. Therefore, we welcome that ISO is in the process of reviewing the ISO 8217/2017 standard and concurs to include a parameter like HC ratio, which indicates the aromaticity of fuel. Thank you.
Thank you, Germany. Now I would like to invite ISO to introduce document PPR-8/5/2. ISO, please.
Thank you, Mr. Chair, and good day to all of you. I hope you can hear me well. ISO TC28 SC4 Working Group 6 thanks Germany and Finland for the final report of a black carbon measurement campaign with emphasis on the impact of the fuel oil quality on black carbon emissions. And Working Group 6 would like to respond as follows. PPR-8/5/1 provides only information on the sulfur and aromatics content of the three tested VLS. Have additional information on parameters such as density, viscosity, microcarbon residue, and calculated carbon aromaticity index and pour point, as these are the initial indicators of the degree to which the fuel tends towards being aromatic or paraffinic in nature. Working Group 6 highlighted already at PPR-7 the fact that in the study the selected fuels were not representative of the bulk of the actual VLSFOs supplied to ships at that time, and continued monitoring the quality of fuels supplied to ships. Document MEPC 76/5 provides detailed information on the quality and test data of more than 100,000 VLSFOs supplied to ships in the first half of 2020 in comparison to 2018 high sulfur fuel oils. The test data show that VLSFOs have a lower minimum density, microcarbon residue, and CCAI, and on average have a lower viscosity, density, MCR, and CCAI, and a higher net specific energy. This, along with a higher percentage of VLSFOs having higher pour point, points to VLSFOs in general tending to be more paraffinic in nature, resulting in general having enhanced ignition and combustion properties over that of high sulfur fuel oils. VLSFOs are therefore expected to reduce the tendency to form black carbon emissions in comparison to high sulfur fuel oils. Document PPR-8/5/1 recognizes that the tested fuels might indeed not be representative for the global market share, and it therefore cannot be concluded that VLSFOs currently on the market produce more black carbon emissions than high sulfur fuel oils. Paragraph 8 of PPR-8/5/1 questions the validity of the calculated carbon aromaticity index and suggests the use of estimated cetane number as an alternative. Since 2010, ISO 8217 has already included an informative annex on the FIA test method. Only a few FIA test strips are available globally and are mainly used for investigative purposes. This means that the test method will not lend itself to routine application to each bunker loaded. Working Group 6 recognizes the fact that a higher aromatic content of the fuel may affect the combustion of the fuel, thereby impacting the emissions. It should, however, not be overlooked that other factors such as engine type, its maintenance condition, and operational performance can contribute significantly more to black carbon emissions. Working Group 6 suggests, therefore, that the suitability of a characteristic indicative for the fuel's aromatics content should not be assessed in isolation of the fuel conditioning and the state of the machinery plant on board where the fuel will be used in. In relation to the request to implement a specification on aromatic content or hydrogen-carbon ratio in the ISO 8217, setting of environmental limits is not within the responsibility of ISO TC 28 SC4, which is to define categories and specifications of the fuel as delivered prior to conventional onboard treatment. ISO TC 28 SC4 Working Group 6 will take the outcome of its fuel quality review into consideration and consider the possibility to include in ISO 8217 an informative indicator to evaluate whether a fuel tends to be paraffinic or aromatic in character. Note also that the heavy fuel oil ban approved by MEPC 75 excludes the use and carrying on board of fuel that has a density and viscosity exceeding 900 kg per cubic meter and 180 centistrokes. And while many of the VLSFOs are less than 180 centistrokes, ISO 8217 Table 2, as currently constructed with a maximum density of 920 kg per cubic meter for an RM810, would disallow an undefined percentage of low viscosity VLSFOs to be used and carried in the northeast and northwest passages. ISO Working Group 6 concludes that document PPR-8/5/1 fails to justify the inclusion of a black carbon emission related aromaticity limit for marine fuels in the Arctic. In view of the multiple influencing factors, ISO would suggest a black carbon limit to be in terms of post-combustion condition. Thank you, Mr. Chairman.
Thank you, ISO. I'd like to ask you to send your statement in a written way to be included in our report. Please do that. Now the next document to be introduced will be the PPR-8/5/3 from IPCA and IBEA, and I invite IBEA to introduce this document. Please, IBEA, you have the floor.
Thank you, Chair, and good morning, good afternoon, good evening to all delegates. You can hear me? Oh, okay, thank you. Our paper, PPR 853, offers some additional information that the Coast Councils believe is relevant to put the results presented in document PPR 851 in perspective. The black carbon measurement campaign presented in document PPR 851, while interesting in demonstrating a link between fuel aromatic content and tendency to form black carbon emissions, gives us only part of the picture for two key reasons. Firstly, the VLSFO samples used in the measurements are clearly not representative of the fuels actually in the market, as they were blended to represent fuels with unusually high aromatic content. It has been clearly demonstrated through test data that the VLSFOs actually in the market are predominantly more paraffinic in nature. Secondly, the black carbon emission measurements reported in PPR 851 were limited to one type of engine. The type of engine used is known to emit significantly more black carbon than two-stroke large bore engines, which are also less sensitive to fuel types than four-stroke engines, like the ones used in the measurement study. This means that the results presented in document PPR 851 may not be representative of neither the engine types used by a large part of the global merchant fleet, nor of the predominant types of fuels used when it comes to VLSFO at least. Another aspect worth noting is that the measured black carbon levels reported in document PPR 851 compared to the emission factor used in the fourth IMO greenhouse gas study were about 80% lower for high sulfur fuel oil HFO. This is a very significant difference which highlights the need to review the emission factors for black carbon. Notwithstanding the fact that VLSFOs are typically more paraffinic and aromatic in nature, and the fact that engine type, condition, and operational profile are key factors in influencing black carbon emissions, the co-sponsor supports ISO's ongoing work to evaluate possible indicators as to whether fuel tends to have a paraffinic or aromatic character. We note that a ban to use and carry heavy fuel oil in the Arctic will effectively eliminate the vast majority of VLSFOs. A number of measures could be promoted on a voluntary basis in the near term to reduce black carbon emissions in the Arctic. Avoiding ships with older mechanical injection engines would be the most effective, followed by employing ships that can use LNG or similarly clean burning fuels in the Arctic. A voluntary switch to distillate fuels, in particular on ships using medium or high-speed four-stroke engines, could also have a positive impact. Thank you.
Thank you, Ian. I would like to finish the introduction of our document, but the time is going, and I would ask now to break for 15 minutes to prepare other things, and then we continue with the last paper, last document from Friends of Europe to Greenpeace International.